Hi, everyone. This is for everyone in ARC 602 and those who are in other programs and other classes. This is the master lecture series that is unique to the fourth semester core studio, where we curate, sorry, I'm taking off the mask, where we curate hosts of people who work at the highest levels of their disciplines. So we have been fortunate to have Erlene Hatfield, structural engineer. We've had Gabor Domokos, who is an architect turned mathematician, inventor of the Gombak. And the third of our master lecture series this semester is Behnaz Farahi. I will introduce her thusly. Trained as an architect, Behnaz Farahi is an award-winning designer and critical maker based in Los Angeles. She holds a PhD in interdisciplinary media arts and practice from the USC School of Cinematic Arts. Currently, she is assistant professor at the Department of Design, California State University in Long Beach. She explores how to foster an empathetic relationship between the human body and the space around it using computational systems. And I will be the first to say that it is gorgeous work. Professor Farahi's work addresses critical issues such as feminism, emotion, perception, and social interaction. She has won several awards, including the Cooper Hewitt Smithsonian Design Museum Digital Design Award, the Innovation by Design Fast Company Award, World Technology Award. She is co-editor of an issue of AD, 3D Printed Body Architecture, and the forthcoming Interactive Futures. I am so pleased that Professor Benahi has made herself available to speak to us today about her work, and I'll turn it over to her. Thanks again.
Thank you, Simon. It's a great honor to be here. Thank you everyone for joining. I have to say that I know many faculties from UPenn, and I'm very excited that Acadia this year is taking place at UPenn. So thank you, and big fan of Ivana Kim's practice, as long as many other faculties who are doing groundbreaking work at UPenn. So with that, please let me share my screen and get us started. I thought that, first of all, before I started, I do have a minor injury, unfortunately, yesterday, so I'm under medication, so I hope I can perform well. With that, I thought to first give an overview of my background. I am from Iran. I trained as an architect. I moved to United States in 2011 to study my second master's degree in architecture at USC. And after that, I did my PhD in media arts and practices and launched my own practice and developed a series of projects at the intersection of fashion, architecture, and interaction design. So this is kind of, today is my presentation. I'm going to take you through the journey of some of the work and projects that I have developed in the last 10 years. As someone who's been fascinated with tactility, texture, and movements of materials, I've been really fascinated to think about ways that I could embed computational systems into the substrate of the materials, as though materials could become machines and machines could become materials, but perhaps a new kind of machine, an emotive machine or emotive matter. And so today I want to talk about some of these concepts that is very important in my practice, from notion of emotive materials, interactive design, to critical computation, which has been a dominant concept in the last few years in my practice. In my work, I'm inspired by nature. Not only in terms of its forms or morphology, which is absolutely beautiful and gorgeous, but also in terms of their behaviors, in terms of its intelligence in responding to both internal as well as external stimuli. So I've been really thinking about ways that materials of the environments could become active, dynamic, and interactive, and intelligent, and in response to the users. So to that end, I started developing series of prototypes, projects, in the range of scales. Initially, they started in the range of, in the scale of architecture, to develop installations that they shape changing and respond in an intuitive way to interaction with their users. So I built a series of interactive walls that respond to hand gestures of the users or spoken words of the users. So as you talk to the wall, the surface and the texture of the wall is changing. I also built an interactive robotic ceiling installation that responds in respond in relation to movement and activity of the people underneath the ceiling. So my attempt in this type of work was really thinking about ways that architecture and human body could create a reciprocal relationship. But these ideas didn't just stay in the world of architecture. I soon fascinated by ways that these technologies could populate around the human body, and ways that these technologies could change human perceptions or ways of communication, or in fact, social interactions. So I started developing series of prototypes in wearable and fashion scales to see how some of these principles from the world of architecture and larger scale installation could be applied in human scale. So going sort of sharing one of the work that in architectural scales I did in collaboration with a steel case company, was this ceiling installation that it was 15 feet by 15 feet, permanent installation at USC Media Arts and Practices, in collaboration with one of our lab, where I really wanted to explore how we could actually build an environment where the environment has computer vision, and the users' movements, the number of people, the activity of people could inform the shape of the physical environments. So to create that actual reciprocal relationship between the body and the space. But I also thought that maybe it's good to take you through some of the research that I do in my practice. Part of my research is about developments of new materials using various types of computational systems, from different algorithmic design tools to use of digital and robotic fabrication, such as advanced multi-material 3D printing technologies. These prototypes that you're seeing, it shows different prototypes where materials changes its properties and its densities, and the composition of materials is carefully controlled through computational systems. But also I explore how we could use different actuation systems, such as smart material and shape memory alloy, pneumatic systems, to more conventional electromechanical systems, such as servos and motors, to really see how we could create materials that they change shape and reconfigure based on information from their environment. In this process, inspired by skin systems, such as scales, feathers, and hair, and to this end, I have developed a series of prototypes that try to understand not only the morphological principles of these forms, but also understand the behaviors of scale systems. For instance, like in these prototypes, you're seeing materials that changes its properties from hard to soft in order to provide a certain dynamic behaviors. And these are some of the other prototypes showing various material behaviors with various composition of material from soft to hard using polyjet printing technologies. While polyjet technology and multi-material 3D printing is providing a lot of opportunities for designers, a lot of time these technologies are expensive and they're not accessible for everyone. So part of my research also looks at material geometries versus material properties. In other words, you don't need to have very expensive tools and machines in order to provide soft dynamic behaviors. Through material geometries, you can actually provide materials that it's flexible and dynamic and change shape, even though the material properties are not that much flexible and soft. For instance, I was using SLS 3D printing, SLA 3D printing using a very fragile material. But we realized that if you print this material in the form of a spiral, the material becomes absolutely soft and flexible and resilient in different forms and flexible in responding to forces from different directions. So these are showing some of the prototypes using SLA 3D printing and some of the formal expressions that could be expressed using a sort of form of the coil and a spiral in its form. So to kind of summarize my material research studies, I look at both morphology and behaviors of materials. In terms of morphology, I look at material properties as well as material geometrical features. In terms of behaviors, I look at sensing, encoding, and responding, which I will dive deep into this just in a few minutes. But one thing that we really soon realized, it was a lot of architects in the field, they're applying the principle of architecture from their design capability and sensibility to a different scale of architecture. In 2017, with Neil Leach, we co-edited an issue of architectural design called 3D Printed Body Architecture, where we featured a series of groundbreaking works by architects in the scale of human body or for the human body. These works include the work of people like Neri Oxman, Nervous System, Nicola Casas, and many others that they were trained as an architect, but they were really exploring some of these principles of architecture in a different scale of architecture. And currently, in a similar vein, I'm co-editing a book on interactive futures, which address the notion of interactive design across the scales, from the scale of wearable and fashion to objects and industrial design, to all the way to architecture and urban scales, to see how interactive design have changed the landscape of design as a field. In my own practice, part of my research is also into sensor technologies. I look at a variety of sensor technologies that allows to capture various biometric feedback information from the users using brain-computer interface and EEG technologies to computer vision using facial tracking, gaze tracking, and various ways that we can read information from the users. In this, I got really inspired by the work of Rose Pickard's from MIT Media Lab Affective Computing Group and the notion of affective computing. Affective computing is about developing a system which try to understand and recognize and detect human emotion, and through the sort of measuring physiological responses from the users. So for me, the interactive design very soon from sort of very conventional gesture-based interaction design moved to something that try to understand and tap into human emotion. But I have to also say that for me, emotion is not something that is just limited to human. In fact, many other species share and experience emotion. And in fact, some of other species, such as mice, cats, and dogs, for instance, their bristle, their furs, as an emotional response to excitement or as a defense mechanism. So for me, emotion is a little broader category of responding to surrounding environment and work as a survival mechanism for both human and other species. So I've been really fascinated to see how, for instance, we could develop environments or variables that act as a second skin, something that it's become an extension of one's body and respond to emotional information, either from the user or from its surrounding environments. These are some of the prototypes from the robotic, soft robotic wearable called Opal, where the garment responds to emotional facial expressions of the people around. So I want to show some of the behind the scene images and videos that shows how this piece came together, some of the mechanical solenoids, electrical parts, as well as the CO2 capsule that allows the inflatable garment wearable for the distribution of the fibers in this dress. We use algorithmic design tool to analyze human skin and human surface analysis and map the height as well as density of the fibers based on the information captured from the human body. So it's become this topographical landscape where each of these fibers are located into the sheet of acrylic. After they all placed in the sheet of acrylic, everything was placed in the bath of silicone rubber. And after 48 hours, it was ready to peel off the material. This process was very fascinating. It was very surgical, and the result was almost like an animal fair. So one of the thing about this project was really to create a second skin where the wearables become an extension of one's body, and wearables become smart enough to capture emotional facial expressions of the people around. So, and if it recognizes people are angry, or if it recognizes people are happy or surprised, it responds with different types of behavior. And the application of such designs could be also seen for people who suffer from understanding facial expressions of people around, people who suffer from a form of autism. What if their garments could help them to blend in and understand the facial expressions of the people around? With the similar vein of work into the notion of affective computing and emotional affective detection, I've been approached by Adidas to design an emotive display case for their newest concept shoe. So this project was an excuse for me to think about the notion of affective computing as an interaction design, how we could design an interactive experience where users and the objects become emotionally engaged into one another. So creates a bond between the object and people. So I don't want to spend a lot of time on this project. I just wanted to share some of the process images and video and talk a little about the interaction, because it was interesting to think about ways that this piece could detect not only users, but their facial expressions and create a persona for this piece. The design of the piece consists of series of pentagon and hexagons that they robotically milled, and they came together, assembled together using series of conventional nuts and screws. From inside the piece was illuminated by a series of LED, addressable LED strips, so it could illuminate from inside out. And inside the piece, it was the concept shoe that was located on a motorized platform, so it could rotate around its axis, and the LED lighting would differentiate based on the information that the camera captured from the users. So the interaction design of this piece was really about developing a persona, a character, like almost what you see in Disney worlds, by developing a character for very abstract objects. So in this case, if the person is detected, the display case kind of wake up and acknowledge the person. If it recognizes that a person is happy, it shares the happiness and excitement. And if it recognizes the person is surprised, it develops different behaviors. So it was really about kind of creating curiosity and sort of engaging experience between people and the object. One of the things about this piece was when you're standing, when we actually had this piece in Germany, when you're standing in front of the piece, you're basically have to kind of move around in order to attract the attention of the piece. So it creates a very engaging experience. If there are multiple people standing in front of the piece, the shoe inside start to rotate around and move in different directions in order to almost find the right person to give attention. So if you want to attract the attention of the piece, you have to kind of move around. So it really creates sort of engaging, playful experience for the users in front of the piece. And it really uses sort of the notion of anthropomorphism in objects to see how we could give a character to an abstract object. Within the same line of thinking, I was the third projects that it was really addressing the notion of interactive emotive design was a piece that was commissioned by a Museum of Science and Industry in Chicago. This was a very special piece. Museum of Science and Industry in Chicago has more than 1.5 million visitors per year, and the museum runs every day from 9 to 5. One of the concepts of this project was hummingbird. Hummingbirds are amazing creatures because they can change colors with the twist of their heads from dark green to magenta. So I've been thinking about ways that materials could change their colors and textures, but also change their shape. But one of the challenges was, if you're going to produce something which is kinetic for the Science Museum that runs every day from 9 to 5, how do you come up with a design that it's robust enough that if parts break down, the museum staff can easily replace those components? For this, we decided with my team that we want to produce these kinetic components, a very modular kinetic components out of electromagnetic systems, and we decided to produce this in-house. So we decided not to go for off-the-shelf product, because a lot of off-the-shelf products, they have many gears and motors that they might break. So we decided to come up with a very simple dynamic mechanism that just rotates along one axis, one back and forth. This was an easy decision in the first place, but it went through many iterations and prototyping, as you can see in these videos, to really fine-tune these actuators. Electromagnetic actuators are absolutely fascinating to work and develop components for, but this was extremely iterative and labor-intensive process. So each component at the end, as you can see, it has many components, a coil, a magnet that will flip from one side to another because of the magnetic field that it produced through running electricity through these coils. One thing about this project, which I was very proud of, was every single components of this piece, from electrical to mechanical to software, everything almost was custom made. We wanted to make sure every components we design is completely robust, and if something breaks down, the staff in the museum can take it out and replace it with a new component. But also, as you can see in this video, this piece consists of 250 actuators, 40 driver boards, 4 microcontrollers, 1 camera, all embedded inside this piece. So it was extremely compact and at the same time, crazy amounts of engineering to make sure everything is going to work. The piece also holds a camera. This is the computer vision, what the camera sees. It can see people's location in the space, as well as their facial expressions. So if it recognizes that, for instance, you're happy, it generates a very nice ripple. And if it recognizes you're frowning, it moves really fast, as though it wants to repel you from getting closer to the piece. One of the conceptual idea behind this project was the notion of sensory substitution. I was very interested to see how, for instance, a blind person or someone with the eyes closed could still sense the world, understand where people are standing, what kind of facial expression they're expressing through the auditory experience of their garments. So with that, maybe I'll just don't talk and I'll share this video without me talking over. So in the remaining time that I have for this presentation, I want to focus my attention to what last few years of my practice was also focusing on, which is the notion of computation. And by that, I mean using computational systems not as an end itself, but to address larger critical questions. And I'm going to unpack that. But one of the things that happened last year, I was one of the co-chairs of Acadia conference toward critical computation, where we really try to address this in Acadia conference, which, by the way, this year is happening at UPenn, which I'm extremely excited about. So in which last year, we decided to have it around the notion of critical computations to address how computation and computational community could address important issues such as participatory design, emancipatory design, critical design, and brought together amazing series of keynote speakers and conversation around these very important topics. In my own practice, I've been very interested in the critical notion of the gaze and surveillance. And I explored that specifically in the series of design projects that I'm going to share for the remaining of these talks. One of these projects is Caress of the Gaze, which is not only a piece of technological innovation, but really address the notion of the broader issues such as male gaze and the female body. So this piece, it's a 3D printed multi-material garment that it's equipped with facial tracking camera, which is almost hidden inside. It can see the age, gender, and where the onlooker is looking. So watch the video and I'll talk. So basically, if you're the wearer, you know which part of your body is being looked at because of the haptic pressure of the garment on your body. If you're the onlooker, you know that your action is being notified because that part of the body is basically moving. So it creates a very, it kind of switched the dynamic of social interactions. This project got a lot of media attention from various media, which was kind of out of control. But at that point, as a designer, what was interesting for me was the conversation around it. Obviously, some people loved it. They emailed me, they really wanted this piece. And some people didn't like it. So it was just, what was fascinating for me to observe was the public conversation around the very sensitive issue of, for instance, male gaze on the female body. Another projects within similar notion of thinking about gaze and eyes was a project that I developed the beginning of 2020, Can the Subaltern Speak? This project is inspired by historical Iranian mask. Masks are fascinating to think about, and it was interesting because I developed this project before pandemic, and it happened that pandemic took place. But masks take on different roles historically and politically, or they take on different roles, and that was something that was really interesting for me. But also, as someone from Iran, I was very intrigued by this Iranian mask, and this Iranian mask worn by certain groups in southern part of Iran, known as Bandari women. And it's been said that they developed as a way to protect these women from colonial patriarchal oppression of Portuguese men looking for attractive women. So obviously for me as a designer, it was very interesting to think about how these women express themselves if the only place is to basically use their eyes. I came across this interesting incident in which Admiral Jeremiah Denton blinks the word torture using his eye blink during his captivity in Vietnam. So this is the moment that the project clicked for me, and I started thinking about ways that we could use eyes as a way of communication, and thinking about sending secret messages and developing secret language. Having said that, the use of the secret messages is nothing new. In fact, women during the lockdown used signal words to ask against domestic abuse. But this project was also through the use of artificial intelligence and machine learning, inspired by especially the work that has been done at Facebook AI Lab, where two robots in experiments started to develop a language together for dialogue. And at some points, these bots started to producing language which wasn't comprehensive for humans. So scientists had to stop this and intervene with the algorithm to make sure that the human understand every dialogue between these bots. But what was fascinating for me was the knowledge is power, and inability to understand the knowledge, it unnerves those who wants to maintain the power. So this project was really about that, really about, from the design perspective, is about how to use the Langer lines and information from the skin to map the design of this mask, to map to those information, but also really thinking about ways that we could develop a machine learning algorithm that generates new type of language. This project, I'm going to actually maybe skip to the parts that is about machine learning. So it uses uses a Markov chain, which is a common machine learning algorithm. And this machine learning algorithm is been trained based on the seminal article of feminist theorist Gayatri Spivak. In her article, Can Subaltern Speak?, she questioned whether it's possible for the colonized to have a voice in the oppression of colonial oppression, basically. So she asked this question. So for me, that was really fascinating to train the machine learning algorithm to see what kind of sentences and words and letters the machine learning would produce. So each of these masks, they produce, and in the video documentation, which you will see each mask produce a language or a sentence, where this translated to a Morse code, and Morse codes are sent the messages through the movements of the eyelashes, the electromechanical components that they're located in the mask, sending and receiving messages between two female who wears these masks. So the idea is really kind of to think about, to sow anxiety to this type of patriarchal oppression, and to see that how such a design could allow developments of a new type of language. These are some of the ways that machine learning algorithm has been translated to a Morse code. Maybe with that, I'll just go to the next slide, where it shows the final design. So one more thing about this project is that obviously the project brings together thoughts about the world of critical theory, design, and feminism all together. And however, it's also a speculate on what are the ways in which we could empower these marginalized women to have a voice in the situation when their voice has been oppressed. and speculate ways in which they can develop a new type of language, which is not perhaps linguistic, but it's perhaps a nonverbal communication between the two masks and their wearables as the extension of their bodies. And the last projects that I'm excited to share, because it's also the newest projects that I did last month in Milan for Milan Fashion Week. It's also addressing critical issues of the gaze. So I was approached by fashion brand called Anakiki for installation for the runway show during the Milan Fashion Week. This was a very unique opportunity and very interesting context to showcase my work. But also I was very excited to think about ways where we could subvert or challenge the runway show, the process of runway. Fashion obviously is an important medium for culture. It's an industry that also has a huge tradition of female objectification and sexual harassment. So for me, it was an excuse to think about how we could use computations and robotics to think about ways that we could perhaps subvert or challenge the logic of runway. So especially as these female models are always observed, they always objectified in a certain way. I've been thinking about questioning really, what if this model or performer on the runway show could subvert and return the gaze? What kind of uncanny feeling it might have if there is a model with 4 robotic arms that look back at the audience. So with that, I'll just show a video of it. I noticed the video was a little jumpy. Anyway, this video is on my website for those of you who are interested to watch it. I noticed it was a little jumping on my end. One of the things about this project, obviously, was to think about ways that we could challenge this logic of runway show. But maybe I thought that just take a little 2 minutes and talk about the process of production of this piece as well. I was working with Universal Robot UR10E to mount these 4 monitors on the robotic arms. But for the behaviors of these robots, I really wanted to have this sort of very anthropomorphic, very creature-like movements. So for that, we used VR headsets and translate the hand movements to the movements of the robot. There is a headpiece that the model wears, and where it has a very 2 small cameras that stream the video data from her movements of her eyes to the monitors that they're mounted on each robotic arms. So some of the challenges, like technically, was also synchronizations of movements of not just one robot, but multiple robots, to see how they could be sometimes mirrored, sometimes they're absolutely synchronized. How do you choreograph their movements together? and what kind of uncanny feeling it has when you have the eye that almost feels like these robots have eye themselves. I think this is one of the fascinating moments that everyone, when the fashion show is actually finished, usually people just leave the building to go to the next fashion show, but everyone were just moving toward this piece to take pictures, and there was this moment of observer looking at the observed. That was very fascinating to watch. Maybe to wrap up, I just want to say that as an interdisciplinary designer who trained as an architect, I'm extremely excited about the new design possibilities through the use of computation. Not only to just, answer existing questions, but actually to come up with new challenging questions, which challenges dominant outlooks and questions assumptions. And I'm really excited about that. With that, thank you very much. I'm looking forward to your questions, comments. Yes, thank you.
Thank you, Behnaz. That was such impressive work. I mean, the depth of technological research and then giving agency to, let's say, provoke against the Western male hegemony or the male gaze, I thought has been so beautifully produced. Sorry, I'm hearing echoes all over the place. But I'll turn it over to see if anybody has any questions for Behnaz. Okay, I'll start, and this is generally how it always goes. So my question, Behnaz, is, do you foresee like almost an elliptical arc where your work, you started off as an architect and then you've gone so far into the world of interaction design and critical design that you see it returning ever to the, let's say, the orbit of architecture? And I can imagine all kinds of skin and facade and surface systems for your work? Or do you see that there's a kind of, let's say, parallel strands of your work that perhaps don't have to necessarily meet?
No, I mean, definitely, I think, first of all, thank you for your first comment. I appreciated that. But I think in terms of returning almost to a different scale, I love changing the scales. I think there's something, I found pleasure in changing from the scale of, jewelry to fashion, all of a sudden to installation. And trained as an architect, I think, like many architects, is always the desire to go larger. So one of my hope is for my practice to actually move to more larger scale installation, public art, maybe a facade of a building. But what I am interested is to bring the critical narratives and storytelling into my design. So that is, I think, the underlying focus of my practice that I really hope that to have. So either it's installation or it's the public art, or maybe if one day it's facade, how could I tell an interesting story? And I think as someone who did PhD in a cinema school, I think one of the things that I learned from the cinema world is the importance of narrative and storytelling. I think this is something that perhaps conventionally architects are dismissing. We are very good with the spatial configurations and design in 3D and all that, and understanding users' needs. But we don't tell the stories, or conventionally we don't tell the stories. But I think the importance of narratives and stories is something that it could provide really interesting lens for the world of architecture and design. So my hope is to get to public art installations or larger scale work.
I was just gonna jump in, Behnaz. Hey, how's it going? Amazing lecture. It's
Thank you.
fantastic to see how your work has progressed over the years. It seemed just a kind of maybe a question to you about computation and design.
Oh,
It's
this is
interesting.
Daniela.
Yeah.
Oh my God, I couldn't tell. With the mask
Oh.
on, I couldn't tell. Good to see you.
I know, it's so nice to see you. I think it's the last time I was in like Tongji, right?
I think it was in Athens.
Oh, Athens, that's right, yes. True. It's just, I mean, it's interesting to see you move also into machine learning, because I think, you know, there's a lot of opportunity there. So I guess with that, even in moving into large scale installations and all your kind of interactive work, the question is like, what's the next frontier, I guess, which you kind of started to answer at the end, but I'd love to hear some of your comments about that computation as a kind of what's the next frontiers there.
You know, my hope is to, besides the fact that I really want to move to do larger scale installations, I really also, it's important for my practice to see where I'm going with it, like be very selective on what kind of projects I want to be working on. My ultimate goal is, even if it's a commission project, but how can I make sure that I'm very selective on choosing those projects that allow me to bring some critical conversations in those projects. Being in academic world, unfortunately, would allow me to do that, to be selective on what kind of works I want to go for rather than any works that come my way. So my hope is really to find those right projects that I think that it aligns with my own research interest, with the type of work that I am interested in, notion of critical theory, work that maybe address political issues into the design, to see how computation is not just for producing, you know, sexy, beautiful outcomes, but you can actually tell something more. That's something that I really hope that to sort of more and more interject in my work.
Thank you. Amazing.
Thank you for the great question.
Oh, hi. I was wondering if your work focusing on the human body scale has made you thought about architecture differently. I guess by focusing so much on the human body, like what would you say to architects?
I mean, I think my fascination with human body scale operation, it really started from, you know, architecture education, where we always place these human models or human image into the renderings of architectural scales. I always was kind of curious that who is this human? What does it do? And always like, we just don't know. We just put them there as like a sort of a standard human with a certain proportion. But I really get fascinated by ways that we could actually develop a relationship between that human who's standing in that architectural scales and the form of the environments. So I think for me, it really started from that. And when I was architecture students, I was always constantly interested in that relationship of that image that we put and that the space that we put around it. And then when I got more and more into interactive design, I saw that as opportunity, as a way that we can come up with interesting, engaging experience rather than something which is a static. What if the environments, what if the architecture can change mood? What if the environment can change your emotion, how you feel? And not necessarily just about human proportion, but really tap into human emotion through the use of interactive technology. So that's how it started. And then it's got more and more and more.
Oh, thank you. Yeah, your work is very cool.
Thank you. Thank you, Megan. Someone is not muted, so it's very difficult. No, perfect.
So Behnaz, if it's okay, hi, this is Franca.
Hi, Franca.
Hi, how are you? Good to see you.
Good to see you.
Likewise. Again, thank you so much for just an absolutely stellar set of work, but also questions. And so for the first time, I just had this image. By the time you came full circle to the last project with the kind of return gaze of the robotics, I just had this question that I was hoping that you could help me with, which is, what would it be like if we assumed, as I think you are, that in the same way as we see correspondences with the emotive capacity for even mice to express themselves, and if we assume that we ourselves are able to do that physically and with our projections, the things that we actually design and build, could you begin to speculate on how we could return to the building as a site that helps us critically question precisely the kinds of questions that you're asking? Because I imagined that there's a world out there where we have yet to consider the way in which our buildings, in fact, hold precisely these interrogations of gaze that many of us are just assuming are neutral and not there. And I suspect that you probably have some ideas about where we could start to look in these embodied things we call our buildings. I would love to hear from you.
Yeah, thank you, Franco. That's a wonderful question. And I think it's a question that I probably will keep thinking about it for some time. I think it's just the question of a scale when you go from one scale to another is important. But as you said, the notion of surveillance and gaze, what does it mean for our body to be observed by another body? But what does it mean for our body to be observed by the building, right? We're already occupying buildings that we are observed by the surveillance cameras that they're located in various locations. In fact, in my building, there is, app that you can look at yourself or anyone who enters the building. So if you want to spy on other people, you totally can, because you can go back in time. So you have this almost augmented memory through the use of surveillance in building. So all sorts of ethical issues would come about, because it's not about one-to-one interaction, but it's almost building to many bodies interaction. So it's fascinating. I think one of the architects who very early on talked about the notion of surveillance in architectural experience of architectural scales was Liz Diller and Scafidio. They actually did projects related to experience of surveillance in the building. And surveillance and gaze is one approach to really see how these technologies could be occupied or addressed in the larger building like scale. I think you could also tap into really thinking about all type of data that our building is capturing from us, from sort of smart devices to thermostats, learning from occupants' behaviors. Not only these are, yes, it does provide some exciting opportunities, but at the same time, I think the ethical issues related to this is yet to be unfolded. We are really kind of tapping into understanding what it means for our data to be captured in data scales, and what kind of and by understanding that, I think the next level is how to question it, or how do you come up with new narratives for such a scale. So I think that's something that I will be very interested to explore. I don't have an answer yet, or have done any project in that scale yet, but I think it's interesting to think about the notion of surveillance gaze in that larger scale, perhaps public buildings. I hope I answered some of your questions. Thank you.
I'm Richard Farley, and I teach structures, and I'm very impressed with what you have. One nostalgic thing that came to mind, are you familiar with Kurt Schwitter's way back Schwitters. He's
Oh
from
no.
Nevada, and he designed rooms that were on pulleys and devices that as people moved into the room became in balance with them. So it's a very, very analog. But that's not my question for you. My question had to do with the gaze and what that tells the person that's receiving the information. And have you thought about the next step of how to create safe spaces, even within the garment, that would either through an embrace to take care of somebody that's anxious, or to be able to create something that's defensive?
Well, that's fascinating. I think it's something that I have been thinking, or when, for instance, that fiber optic dress go to defensive mode, it was one of the intention to really, when you detect something is aggressive around you, how do you go to defensive mode, right? So there were attempts to really think about defense to some extent. I don't know if I have done anything in particular to, let's say, like calm you down. I've been thinking about ways that architecture could do that, ways that perhaps the environments could detect if you're stressed, and then it can basically calm you down when you're really stressed, make you feel safe. But I think this is, this is something that it is interesting. It's also, if you really go through it, at the same time, it's challenging, because sometimes we don't want to be all the way calmed down or feeling completely relaxed, because sometimes we do need a stress. We do need the sort of a little of even anxiety to go ahead, to move forward, which is interesting. So I've been thinking about how do we really want almost like equilibrium? Do we want, if you're, let's say, anxious, to always calm down, and if you're always calm or lethargic, always to like bump up, or is this more complex? So although it sounds very interesting and I've been thinking about it, I'm still not sure what is the answer exactly to this. I think it's a little more complex because we need to understand the context more.
Thank you. Excellent.
Thank you.
Are there any other questions for Behnaz?
Hi, I have a question. First of all, I'm a very big fan. I've followed you for years, so I really appreciate you coming here. But returning to the conversation of the gaze and the projects that you have done, and your behavioral analysis of the face and the eye tracking, I feel like there always has to be a question regarding to COVID. How has the use of the masks that cover most of your face affect your design process, if it did at all, during these past couple of years? And how do you plan to adapt to that in the future?
Like if we are living in the world that we have to wear a mask.
Right.
Yeah, I mean, it's interesting point. What was interesting was the mask project that I did. It was pre-pandemic, the idea, and I was building it while pandemic has happened, right? But I couldn't stop thinking about ways that, I mean, obviously for me, the starting point was, well, these women have to cover their face except the eye. How do they express? But also equally right now that we have to cover half of our faces, how do we express? There are information that we are missing out. There is like this micro expressions in our face movement that we are missing out. So I think for like a smart, intelligent design, there's so much possibility to think about ways of expressions, and also obviously detection, but also self-expressions. In terms of specifically what you asked about computer vision, reading, facial expressions, I haven't like after we're wearing masks, like I struggled with this, but I also see a lot of, for instance, my students right now, they're designing interactive experiences with the robotic arms and camera. So they're designing engaging interactive experience with the robot. And one of the challenges is having a mask on. But there are algorithms that allow you to still detect the face even with covered masks. So this was something that right after pandemic, you see the sort of emergence of a new type of algorithms that still is able to detect people's faces, even though half of their face is covered. But the question of self-expression is something that I think I agree that we need some augmented expressive elements when we're covering half of our faces.
Thank you.
Thank you.
Behnaz, thank you again. That was an exquisite presentation. It speaks on the kind of redistribution of power, also as technology that is beyond the nostalgic project that I think I see a lot of. Your work is just beautifully done, and I've got to say I'd like to speak more about it, but we'll draw a conclusion here.
Thank you so much, Simon. Of course, and thank you for the great conversation. Thanks everyone for great questions. Yeah. Vinka.
Hi. Turn your mic on the screen. Thank you so much for an amazing lecture. That was super inspirational.
Thank you. And I can't wait.
You.
I'll be in UPenn for Acadia, so I can't wait to meet everyone in person.
Oh, great. Good, good.
Yeah.
Come by for a coffee.
We'll definitely. Coffee, drinks, foods.
All of it.
We'll be there.
Great. See you soon. Thank you, Simon, for organizing.
A pleasure. Thank you again, Behnaz. I'll see you all soon. Thank you again.